Welcome back to the video for chapter 3.4. We're still working with polynomials. We're learning lots of cool things about polynomials and how to find their zeros and x-intercepts, which is a zero, an x-intercept, and solutions to equations. That's what we're going to focus on in this lesson. So your students are going to learn how to find the rational zeros of a polynomial. We learned a little bit about the remainder theorem and zeros in the last lesson. We're also going to learn how to solve polynomial equations by finding the zeros and how to apply Descartes' rule of signs. So example 1 says, show that x equal to -2 is a zero of this polynomial. Use this to factor completely. Okay. It says, let P be a polynomial function, let C be a real number. Then the following are equivalent statements. That is, if one of the following statements is true, then the other two statements are also true. So if we put C in for the input and the result is 0, then we know that x minus C is a factor. We showed this in the last lesson, and we also know that C is an x-intercept or a 0. So let's just try this. Fill in the table. Okay, so for the P of x function, if we know the factor is x plus 6, then we know that the x-intercept is at a -6, 0, and we know that the 0 is a -6. And likewise, if we know that the 4 is a 0, we know that the x-intercept is 4, 0, and that the factor is x minus 4. And for g of x, if we know the x-intercept is 2, 0, we know that 2 is a 0, and we know that the factor is x minus 2. So these are interchangeable. Okay. The rational zero theorem says a non-constant polynomial function p of x of degree n has at most n real zeros for where each zero of multiplicity k is counted k times. So if we have a polynomial, like we described in previous lessons, they have to have integer coefficients. And so then you have all p over q, rational zeros. P has to be a factor of a0, so P is a factor of the constant. Let's write that down. And then Q has to be a factor of a sub n, which is the leading coefficient. It says find all the real zeros of P of x. So the possibilities are all of the factors of a plus or minus 1 over a plus or minus 4 and the factors. So it could just be plus or minus 1. It could be plus or minus 1 over 2, or the plus or minus 1 over 4. Those are all of the factors. So what I do is I start with one that's an integer. I try that I try that first. And we can do that. 1 is nice because we could put 1 in quickly here and just see if it comes out to be 0. So if we say P of 1, we're going to get 4 times 1 cubed plus 4 times 1 squared minus 1, which is 4 plus 4 minus 1 is 6. So 1 is not 1. We could try a -1. So 4 times a -1 cubed plus 4 times a -1 squared minus 1 minus, if it's a -1, it'd be +1 here, minus 1. So this would be a -4 plus 4 plus 1 minus 1, and that comes out to be 0. So we know that -1 is a factor. Okay, so if we know that -1 is a factor, then we can use synthetic division to factor that. So I'm going to use my coefficients of 4, a -1, and a -1 to find out what it factors to be. So I'm going to bring that down. I get 4. So -1 times 4 is a -4. That adds to 0. A -1 times 0 is 0. That adds to a -1. A -1 times a -1 multiplies to 1, and that adds to 0. So that means I have 4x squared. There's no middle term, minus 1. Okay. So this can factor into a difference of squares. So I know that 4x cubed plus 4x squared minus x minus 1 can factor into x plus 1 times something. And that something is this difference of squares, 2x minus 1 times a 2x plus 1. 2x minus 1 times a 2x plus 1. Because 4x squared minus 1 factors into the difference of squares. You can also use Desmos to validate that. So let's go and put in this original polynomial into Desmos. I'm going to turn this one off. So we have y equals 4x cubed plus 4x squared minus x minus 1. And then we can click on a 0. So there's one at -1, which we already proved. There's one at a -1/2. And there's one at a +1/2. And that is what we would see if we set each of these factors right here equal to 0. So that would be x is a -1. This would be x is a +1/2. And that one would be x is a -1/2. Now let's go to Desmos and just use Desmos to find the real zeros of this one. So we can have at most 3. I'll share my screen here. If I turn this graph back on, I've got, here's one at a -2, here's one at a fraction, and then there's one at a fraction. And those are equal. Okay. And you can see that they cut through so that they each have only one multiplicity, what we learned in the previous lessons. Example 5 says, solve the equation here. So to solve this equation, let's factor out what we can here. X squared let's see if we can factor out an x squared. And we'll have 2x squared plus 3x minus 6 here equals 5x minus 6. We'd have to factor this, and then we'd have to set it equal to that. Why don't we just bring everything to one side. So it's 2x to the fourth plus 3x cubed minus 6x squared minus 5x plus 6 equals 0. And what we can do is we can look for a 0 here. So we're looking for all of the factors of plus or minus 6 divided by all the factors of 2, plus or minus 2. So we could have all the way from plus or minus 1, because that 6 divided by 2 is 3, so that's a possibility. All the factors of 6. So we also have the plus or minus 2, plus or minus 6. We could have the fraction of 1 over 2 is a possibility, but we're going to start with these integer ones. So what I do is, if I'm going to find them by hand, I always go to Desmos and type it in and at least get one to start. So y equals 2x to the fourth plus 3x cubed minus 6x squared minus 6. So I can see here that I've got a -2, a -1.5, and a 1. So I can do any of those. So let's start with 1. And it looks like these two have a multiplicity of 1 because they cut through, and this one has a multiplicity of 2 because it touches. So 1 is 1. So I'm going to use my 2, 3, a -6, a -5, and a 6. And I'm going to bring those down and do synthetic division. So 2, that gives me 5. 5 gives me 1. A -1 gives me a -6. And a -6 gives me 0. Okay. So there's one of them. One of the factors is x plus, one of the factors is x minus 1. Okay. And so now I still have 2x cubed, 5x squared minus x minus 6. So we showed that it was touching. So this is another, x minus 1 is another 0. So we can do another one of these with 1. So I can bring my 2 down. This is 2, that makes 7. 7 is 6, 1 and 6 is 6, and I get a 0. Okay, so there's my second one. So I have x minus 1 happens twice. And then this is 2x squared plus 7x plus 6. Can this factor? I'm going to see if I can get it to factor. 3 and 2. Guess and check. So 3x and 4x is 7. Yep. So I've got the factor of 2x plus 3, and then I've got x plus 2. So this x minus 1, x equal to 1 is a multiplicity of 2. And let's just write out the 0. So the 0 is 1 and the multiplicity is 2. Here the 0 is a -3/2. And the multiplicity is 1. And here the 0 is at a -2 and the multiplicity is 1. So if we want to be able to see the possibility of zeros quickly, we can use Descartes' rule of signs to do that. It says, let P of X be a polynomial function with real coefficients and a non-zero constant term. Let K be the number of variations of sign of P of just X, and let M be the number of variations of sign when you put a negative X in. Okay, so let's just find that. So P of X, we have positive, negative, positive, negative, right? Positive, negative when it's just X. So we change signs once, twice, 3 times. So the number of positive zeros of P is either K or less than K by an even integer. K is the number of variations of sign of P of X. So K is equal to 3. So we have 3 or 1, because it has to be by an even integer. So I have to subtract 2. So 3 or 1. So there's 3 or 1 positive zeros. And then P of a negative X is 4 times a negative X to the 4th minus 3 times a negative X cubed plus 2 times a negative X minus 1. What would my signs be? So this would be a positive X. That would be 4X to the 4th. This would end up being a negative X cubed. So that will be a positive 3X cubed. That'll end up being a negative 2X minus 1. So I don't change my signs here. I change my signs once here, and I don't change them here. So I only get once. So here, M is equal to 1. The number of negative zeros of P is either equal to M or less than M by an even integer. So there's only a possibility of 1 or 3 positive zeros and 1 negative zero. Let's put that one into Desmos to see. Y equals 4X to the 4th minus 3X cubed plus 2X minus 1. Okay, yes. So that's a negative 0. There's only can be one of those. They said that. And then there's 1 positive. So we were right. Let's go back to this example that we used Desmos for, and let's do discards on that. Discards rules. So K is equal to the number of positive changes. So we go from positive to negative, no change, no change. So there's only 1. So there can only be 1 positive 0. And then M, if we put in a negative X, P of a negative X, this would be a negative X cubed. And then that would be still a negative X squared. And then that would be a positive 7X and a minus 2. So there's no change, but there's a change and there's a change. So there could be 2 negative zeros. 1 or 2 or none. Okay, and so let's go back to look at this one and see what we ended up with in Desmos. That was this one right here. We had 1, so when we click on this, we had 1, 2 negatives, just like what we said, and there was 1 positive. That's pretty cool. You can use the discards rules to figure out how many positive and negative zeros you're going to have. Touch me back for another video.